This is the complete explanation video of my project LifeOS made for Identity Exhibition 2025 organized by Design Equal in collaboration with Sentry. Let's start.
The whole backend is made using Express.js, and I've used multiple services like the Multer, the .env, and different libraries of JavaScript itself. But I'll not talk about that. We'll talk about the high-level design and how things work, so the people who are from non-tech can also understand how the whole process of backend works. Let's start. Firstly, the input is going to be provided. That's going to come from the lenses itself. It has a mic that's going to provide the input. The input is going through the speech-to-text service powered by OpenAI's transcriptions. It provides multiple voices, so in the front end we can set the voice we like. Nextly, it goes to the text intent service. This is the part that decides whether that voice can be in any language. It can be remember this, or it can be ye yaad rakhna. It can be in any language. That needs to be transcribed, and that needs to be understood that what that particular sentence means. This particular service decides it. The Gemini receives a well-built prompt and decides what service to go into. Firstly, it decides whether that particular input requires a image or not. First, that is decided. On the basis of that, it decides if it needs to go to the ESP32 and require an image, or if it's a general text query. Suppose we say we hold a food product and we ask what's this, or what are the calorie values of this. Then it will decide that I need to see something. Then it will go to the ESP32. We'll click an image, and that image with that particular text is going to go to the Gemini. Then it will give an output, and the whole process is going to go forward. On the other hand, if we say it's a general text query, it's just asking what's the current date or what this particular animal is. If it's a general text query, it's going to be answered simply just by using the power of Gemini Flash 2.0. Then it can be categorized into a save note. Suppose we say write down what I'm saying, or या फिर लिखना जो मैं बोल रहा हूँ, anything like that. It will transcribe the meaning and it will send it here. Then whatever the person is saying, that will be saved inside the database. Then it can be an agentic input. Suppose I'll say what are the important emails I received today. Those emails over the last 24 hours are going to be searched, and that whole process will be done by the AI agent. And finally, it will give out all the important emails and it will tell it you that. Then the complications come inside. After the ESP32 has captured the camera, this particular condition will meet on multiple processes. Whether it can be a save face or recognize face or even save something. I'd say there's one query saying, what is this food? That's going to be simply replied. Or remember this particular face. Then that face image is going to be captured and kept in our database. The path of that particular image is going to be kept in the database so that we can reduce the load over the database. Or it can be a recognized face. If we look at someone and ask, have I seen this person, or kya maine ise dekha hai, or any other language, it will look up in the database, look up at every single file and tell us whether it is or not. The images are going to be saved with the names of them. So basically it will go to every single. So basically that's how it will decide whether they know this person or not. If they know it, they'll just tell that yes, I know this person, his or her name is this. If we look at the other side, this is the save remember service. If I say I've kept this pen here, remember this. Looking at this, I've kept this, remember this. Then it will remember this particular thing. And if I ask, do you remember where I kept the marker? It will tell me that you remember that you kept it on your hand or something like that, whatever the image says or that meaning says. Then finally, all these queries are completed by the services. Then these all go to the TTS service. A final text input is generated based on the image, based on this, based on that, based on this. Save note have a constant output. Basically, the note is saved. Or I would say, if I say remember this face, then it will say that yes, remember this person as the name. If it's a general text query or something like a general text query with an image. Then it will give a final text reply and it will go to text to speech service. Again, text to speech service is being done by OpenAI transcriptions. All other services are being provided by the Gemini, but only the speech to text and text to speech are working using OpenAI. Then these will go to two different places, one to the WebSocket and one to the res.json. Basically, I'm giving two different outputs. One for the hardware, the mic and the speaker that the lens is going to receive, and second for the UI. The UI is going to display different things like the audio URL, final reply, and based on that, we are going to modify the UI or provide details to that. On the other hand, the hardware is going to receive these, and based on that, we are going to output the voice. If we look at the database, I've made 4 to 5 different fields for it, different models for it. Firstly, it's going to save every single input we are giving it to it. Secondly, the images that we have captured, the faces that are being recognized by us, or the notes we have saved. And finally, this. The ESP32 also has a location coordinates using short GPS application, short GPS library. It's going to give coordinates every single hour. Every 1 hour gap, it will give us coordinates of a particular location where it's located. So that's how we'll get the location of that particular person who is wearing it. It will be saved and it will be saved in the database. It can be used in multiple ways. That's all the part of front end. I think that's it for the backend part. This is was everything that supports the front end. There were more things, but this is like the high level overview of the entire structure. Yeah, looks complicated, right? It is. Let's finally understand how the hardware part works on it and finally understand what this mess is actually doing. Let's start. Firstly, this was the hardest part of the entire project as I was new to hardware and this was the first time I've ever touched a Arduino. Let's start. Firstly, this was the main component, the ESP32. It is a processor that has Wi-Fi and Bluetooth in it and also a flash memory. All the coding was done using Android IDE and FTDI. FTDI was used to push code in this. It was connected to a capacitor to control the flow of electricity in case it needs more. It was connected to a switch, then to a diode, because apparently this battery was too powerful for this. So what it does is, it basically decreases the power. That's all it does. It decreases about 0.4 to 0.5 volts of battery. That diode is connected to the TP4056. This is a charging module and can be used to charge the battery that is attached in the lens. Now you see, this TP4056 had two ends. One for powering the entire thing and one for charging the battery. The LiPo 3.7 watt battery is attached to it that holds the power, or I would say it is the storage for the memory. So we can make it hands-free or we have to connect it to a laptop or some kind of power source. Let's go to the negative side. It is directly connected, thus there is a capacitor in between to balance the powers. And it is connected to the ESP32 negative port, or we can say GND port. The ESP32 is connected to OV3660 camera that provides a 2 megapixel camera for it. It is programmed so whenever the IP address that's connected to this and slash capture is hit, it clicks a picture and sends it to the web. Or if the location is hit, it sends a JSON format coordinates. So this way the hardware working is happening. Now let's have a quick look at the front end too. I've made a browser based website, or I can say React based app using TypeScript and Lucid React for the front end. Let's start. First, let's turn on the hard backend and now the front end. As you can see, this is the home page. Let's connect to the glasses. Basically, what this does is the output WebSocket that receives the audio is being connected to this. Let's do it. As you can see, this is the main assistant page. If we want to, we can see what the input and output is going. I've turned off the mic so that it doesn't take inputs for now. When we connect to this, the backend's output WebSocket is connected. As you can see, if we disconnect it, the output stream is closed. Let's let it stay connected for now. As you can see, this is the chat panel. I've added a dashboard. This dashboard shows the voice interactions we had today, the images captured, face recognized, and notes created, the recent activities, and we can also classify them with the basis of dates. I've used MongoDB as the backend. That's where it's fetching all the data from. This is the permissions page. We have to give some basic permissions. I've made this for like just conceptual basis. It's being implemented, but it's not that many details in this. As you can see, there are some basic permissions, etc. But if we talk about a real basis, then there might be many permissions. Then there is a settings page. There are two themes, light and the dark. Dark is by default. We can update our personal information. Here are the device information and also the overall data that has been stored till now for that particular user. There is a clear all data button that can clear all the data. There is, but I'm not doing it right now because I want to keep it. And as you can see, this is the notes page. Here we can see all of the notes that were taken by us through the mic. Here we can see all the notes that we took from the lenses. We can also delete them if you want. There is a basic help page too with some questions and a basic UI. This was mostly for the front end. It is also responsive, obviously, because it's much likely that a person will use it on a phone rather than a PC. As you can see. So that's all for the front end. I've not put much attention to this because the overall project is highly based on backend and the hardware part. So I've made this, but it's not a ready thing or like much of the configuration is not put here. Other than that, I've kept a minimal interface and the UI. Yeah, that's pretty much it. This is the whole front end.
So this is the final execution video of my project LifeOS in Identity Exhibition. So let's start. Firstly, let's have a look at the actual hardware. This is how it looks. This is the battery. This is the ESP32 with the camera. The switch is here. There is a capacitor and there is a TP3046 for the charging. Firstly, it's chargeable. As you can see, this is the red light. When this battery will be fully charged, the blue light will be turned on. For now, let's remove this because we are going to run it hands-free, not on a charging port. Okay. So let's try giving it an input. Hi, how are you?
I'm doing well, ready to assist.
So this was a general text reply. Now let's try something different. Can you tell me what's written on this page and also tell me the meaning of it?
Here's the information you requested. The page says education is a privilege, not a tour. Education is a fundamental human right, not a luxury. Every child has the right to quality education.
As you can see, it can read and even decipher the text for you. Now I'm just plugging in the charger just so it doesn't disconnect. I've already gave both a vision and a text-based input, so it's truly hands-free. But the battery is like 220 volts only, so it needs constant charging obviously. I could power it with a better battery, but this is just a prototype, so let's power it. As you can see, it's charging. Let's start with a simple text input first. Do you know who's the current president of India right now?
Current president of India is Drupadi Murmu.
Okay. Now let's try giving it a vision-based input. What's in front of you?
An apple.
As you can see, it's giving a simple vision-based input. Now let's try giving it a more complex image-based input. As you can see, it's a packet of oats. I'm placing it here just so it can see it. Now let's try again. What's in front of you and is it healthy to eat?
On the image, there is a packet of Quaker oats in front of me. As for whether it's healthy to eat, oats are generally considered a healthy food choice.
Okay, that was nice. Let's try something else now. Okay, now let's try taking a note and see how that process works. Take a note and write what I'm saying, okay?
Okay, what's the note?
Tomorrow I need to complete this video, upload it because day after tomorrow is the final date of submission.
Got it. Save to your notes.
As you can see, it's saved. Now let's see if it actually is. So this is my MongoDB compass. And as you can see, these are the notes. And as you can see, it has stored the note that we just gave it. Now I'll showcase how this remembers the face and does face recognition. Remember this person as Mukul Vassi.
Okay, I'll remember this person as Mukul Vasi.
Okay, it has recorded and saved the face. Okay, so it's a different day and I wanted to try the face recognition on a different day because if I would have done it yesterday, it would have been a almost same or identical picture. And that doesn't truly represent the power of face recognition. So let's give it a try. Shall we? Do you recognize this person? Okay, let me just let's see if it works.
I recognize this person. This is Creator.
So as you can see, it recognizes the face. It takes a very long time, as you saw. It's because all of the photos that are being sent to this are getting saved. So it has to iterate to every single picture and compare them separately. And that's a tedious process. It can be getting fast, but I'll have to make a complex algorithm for that. But for now, it works. Okay, let's now try something that's useful in a real world situation. Hey glasses, what shoes should I wear? I'm going for a walk.
Wear the purple pink lace-up shoes, far right. They offer the best cushioning and support for your walk.
Okay, they recommend this one. Perfect. Okay, now we'll ask about this medicine. Can you see and tell what this medicine is?
This is Ambropen TG syrup, a combination medicine containing ambroxol, guaifenesin, terbutaline, and menthol. It is used to treat a productive cough. Always use it under a doctor's guidance.
Okay. Let's give it a follow-up too. Should I take it if I have cough?
I cannot advise you to take it. This medicine is for a specific type of cough, productive wet, and contains strong ingredients that require a doctor's prescription and guidance. Please consult a doctor or pharmacist before taking any medication.
Okay, so it basically can't tell. And that's, I think, the correct thing to do as an AI. Okay, now let's try an input with this book. Have a look and tell me what this book is all about. Also, give me a little summary about it.
The book Deep Work by Cal Newport argues that the ability to concentrate deeply and without distraction is the key to producing elite level work quickly and mastering complex skills. It provides rules and strategies to train your focus and maximize professional success by prioritizing cognitively demanding tasks over shallow, distracted work.
Okay, that's enough. You can shut up now. So I've tried giving it different inputs, and it's just that I can't think of any more. So that's it for now. I think I've proven the power and what these LifeOS lenses can do within the 15 days of development. They can achieve the basic visual level things and somewhat complex too with face recognition too. If we talk about the better versions available in the market, like the Ray-Ban glasses that cost 40,000, it's far better than this, obviously. It took me around 1500 to 2000 to make this. So comparatively, I think it's doing pretty good. But it's still in development phase and it needs a lot of progress to be made. You know, the delay in the voice, sometimes it doesn't capture the correct image, sometimes it gives a delayed image, a previous image. So all that needs to be worked upon. But for now, I'm happy with the results.